Alright, this is a review of how to convert units, and I'm just going to work through some demonstration problems. I encourage you to pause the video as necessary and take notes so you can get this procedure. You will have to use it. Alright, let's look at our first problem. The number 190,000 grams is a bit awkward. Represent the same value in kilograms, kg. Alright. Working any problem, we need to know what our given is. Let's circle the given here, 190,000 grams. That's going to be important. What are we trying to do? We want kilograms. We're going to convert. We want to go from grams to kilograms. So the very first thing we're going to do is write a map or algorithm of what we're doing here. We want to go from grams to kilograms. So in order to go from grams to kilograms, we need a relationship between grams and kilograms. Now, many of these conversion factors between units, especially metric units and some metric and English units, are inside the back cover of your notebook that I gave you. So in this case, 1,000 grams equals 1 gram. And we can assume those numbers are exact. They won't affect our significant figures. So we can take, once we have a relationship between the two things that we want, we can write two potential conversion factors. Because these things are equal, we could divide both sides of the equation by 1 gram. We'd get 1,000 grams over 1 gram is equal to 1. Or we could divide both sides of the equation by 1,000 grams. We get 1 gram over 1,000 grams is equal to 1. Excuse me. So our potential conversion factors are 1,000 grams over 1 gram. We can say 1,000 grams in every 1 gram, or we can say 1 gram is equal to 1,000 grams. We can multiply by these things all we want because they're both equal to 1. Sorry, 1,000 grams is 1 kilogram. 1 kilogram is 1,000 grams. Not sure where I went off there. Maybe it was the cat. All right, we can multiply by these things all day long. They are equal to 1. Multiplying by 1 is the multiplicative identity. Does not change the value of your quantity. So we're just going to take this same quantity and we're going to express it in a different units. So once you have your potential conversion factors identified, you write your given with the units. Always start with a given. Don't start with a conversion factor. Please, please, please do not write it as 1 over something equals something else over x. Start with your given, multiply by the conversion factor that will give you the right units. We want grams to go away. We need a conversion factor that has grams in the denominator. That's going to be this one, 1 kilogram over 1,000 grams. When I say make this line horizontal with the numerator over the denominator, this is what I mean. This is going to give us 190 kilograms. There are only 2 significant figures. We don't have to worry about all those zeros. They're not significant. 190 kilograms. All right, let's look at another one. If we knew the volume of a piece of aluminum foil, we could measure its length and width and calculate how thick it is. We put the foil on a scale and we find its mass is 1.07 grams. What is its volume in centimeters cubed? All right, so the question is here. It's really nice to understand how this works, but there's a lot of extra words that we don't need to find the answer to this question. We have a mass in 1.07 grams. This is the only number in the problem. It's pretty clear that we need to calculate something from this, so that makes this our given. Let's circle it. And it's in grams. We want its volume in centimeters cubed. So let's write down where we're going here, from grams to centimeters cubed. So, in order to do a conversion, we need a relationship. What relates grams to centimeters cubed? They are different kinds of quantities. Grams are mass, centimeters cubed are volume. However, we spent a whole week studying density, and we know that the density of something relates its mass in grams to its volume in centimeters cubed. So I'm sorry these are a little small. I think we're talking about aluminum. So aluminum has a density of 2.702 in grams per centimeter cubed. Okay, this means that every centimeter cubed of aluminum has a mass of 2.702 grams, and we can write a relationship that 1 centimeter cubed equals 2.702 grams. So we say 1 centimeter cubed equals 2.702 grams. And we can make two potential conversion factors out of that. We can say there are 2.702 grams in every centimeter cubed, or we can say that 1 centimeter cubed has a mass of 2.702 grams. Okay, sometimes I see people put these equal. They are both equal to 1, but their equality is not the point. The point is that we're finding two things that could potentially be conversion factors. So let's write down the given and figure out which conversion factor we need. We are given 1.07 grams of aluminum. All right, we want grams to go away. We want it to give us centimeters cubed. So we're looking for something that has centimeters cubed in the numerator and grams in the denominator. And that would be this one. So we're going to multiply this by 1 centimeter cubed is equal to 2.702 grams. And this is the rate determining step here. 1.07, 2.702, and we get 0.396. What are the units? Well, grams cancel out and give us centimeters cubed. Okay. Third one, and this is what we're doing this week, is converting to moles. But we do this the same way. It's the exact same kind of problem. So a chunk of copper has a mass of 14.31 grams. How many moles of copper is this? So our given is going to be the only number in the problem. We want moles. So we have grams. We are going to moles. And once you recognize you're going from grams to moles, you know that the place to go is the periodic table. The periodic table has the molar masses of every element. This number, which is below the element symbol, is the mass in grams of 1 mole of that element. So copper is over here. I'm sorry, this is a little small. It says 63.55. That means 1 mole of copper is equal to 63.55 grams of copper. And we write that down. 1 mole Cu equals 63.55 grams of copper. So, since this is a conversion problem, we know we want conversion factors. You may get to the point where you can do the two conversion factors in your head, but until then, write them both down. 1 mole of copper is 63.55 grams of copper, and 63.55 grams of copper is 1 mole of copper. Okay, now we've got our potential conversion factors. We are going to write our given. Always start with the given. And we want grams to go away and give us moles. So we're going to want grams in the denominator, moles in the numerator. 1 mole copper over 63.55 grams copper. And this is going to be a little less than a quarter, but let me put it in, 14.31. So I just multiply by everything in the numerator, divide by everything in the denominator. That means 14.31 divided by 63.55. and that gives me 0.2252 moles of copper, and because there's 4 significant figures here, there's 4 significant figures there. I didn't mention it, but there are 3 significant figures here, so 3 significant figures there, and I think I did talk about significant figures in the first one. So there are some examples of how to do conversion factor problems. Write down where you're starting and where you're going, a little map or algorithm of what you're doing. Find a relationship that connects the 2 units. Okay, we looked in 3 different places to find relationships for these 3 example problems. One was 2 very similar units. I happen to know that conversion factor, but it's in your notebook. That was grams to kilograms. Then for grams to centimeters cubed, we knew that that was a density because we spent a whole week studying density. And then for grams to moles, you always use the periodic table. It does not give you an equation. You have to know that that mass on the periodic table below the element symbol is the mass in grams of 1 mole, so that you can always write an equation of this form, that 1 mole equals that number of grams of that element. All right, this is how to set it up. Start with a given. So you find your 2 potential conversion factors, and many of you will get so you can do that in your head. Start with a given, write the appropriate conversion factor that makes the unit you don't want go away, gives you the units you want, and finally at the very end perform the calculation. Notice that you do not reach for the calculator at the beginning of this problem. You go through the steps, get it all set up, then you take the calculator and find the answer.